Hello, I'm Ravihari, a PhD student from the Lifecycle Management Lab at UBC-O under the supervision of Dr. Kasun Hevage and Dr. Rehan Sadiq. In this short video, I'm going to introduce a system dynamics model to establish the long-term economic viability of community-level carbon capturing subjected to dynamic regional conditions and also compare different carbon capturing scenarios based on the point of integration. This model aims to assess the long-term economic viability of integrating carbon capturing technologies into Canadian community emission planning. Initially, an extensive data collection is required to determine the parameters such as community energy demand growth, cost variations, and technology advancements. The model was developed to assess three scenarios to determine the economic viability. If carbon capturing technology has a slow research and development growth, moderate growth, and rapid growth. The system dynamic model simulates three economic viability decision variables. They are avoided emissions per capital investments, net costs per captured carbon dioxide, and finally, the incremental life cycle costs. The model development followed the general steps in developing a system dynamics model where stocks and flows are first identified and then causal effect relationships are established. The current model was simulated using Stella software. The developed system dynamics model provides us with the future economic viability of carbon capturing technologies under different scenarios. The results provide an insight into what areas require attention in making carbon capturing economically viable. Here you can see the developed system dynamics model. This was demonstrated for carbon capturing integration options for two provinces in Canada. They are British Columbia and Saskatchewan, that represent the least and most favorable regions for carbon capturing integration based on the carbon dioxide load to be handled and the infrastructure availability. Now let's move to model results, where three scenarios were assessed depending on 3 points of carbon capture integration. They are grid-only integration, natural gas district heating system, and both in district heating systems and grid energy systems. The model was simulated for a period of 30 years starting from 2020. When we look at the net costs per avoided emissions, for BC it is the highest for grid-only integration option, while it is the lowest for Saskatchewan. Moreover, regardless of the carbon capture integration point, the costs are higher in BC than it is for Saskatchewan. This is because in BC, the carbon dioxide load is very low, therefore lower benefits of carbon sale for BC. When the life cycle costs are considered, for different carbon capture technology advancement rates, it is higher in BC than it is for Saskatchewan. This is mainly due to the existing infrastructure facilities in Saskatchewan. However, it is noted that life cycle costs are expected to drop by approximately 2%. These findings are expected to support policymakers and investors to develop customized regional policies and make investment decisions by considering dynamic regional aspects. Thank you.